Assalamu alaikum and good day. First of all, thank you for your time watching. In this video specially made for CITREX 2021, we would like to present our innovation entitled Intensified Equipment for Producing High Purity MTBE, or also known as methyl tert butyl ether. Before I proceed further, I would like to briefly describe MTBE. MTBE is a component produced from the reaction between isobutene and methanol. It is mostly used as fuel additive blended into gasoline to increase knock resistance and reduce unwanted emissions. Nowadays, MTBE producers are looking to extend the use of MTBE to sustain their business in the future. And one of them is the use of high-purity MTBE. High-purity MTBE is obtained by purifying industrial-grade MTBE, which is around 98% weight to purity of minimum 99.7% weight. With such high purity, the usage of MTBE can be extended to various applications such as in agriculture, pharmaceutical, cosmetics, food industries, and as chemical intermediates such as solvents. Looking through demands of high purity MTBE in the future. The global revenue of high purity MTBE market is estimated to cross a value of $100 million by 2030. According to Transparency Market Researches, this global boost is driven by increasing application of high-purity MTBE in pharmaceutical and agrochemical sectors. Price of high-purity MTBE is estimated to be 4 times higher than industrial-grade MTBE. This trend has drawn MTBE producers to look at high-purity MTBE as possible income other than MTBE alone. Industrial-grade MTBE contain various contaminants such as unreacted isobutene and methanol, tertiary butanol, methyl sec butyl ether, and water. These contaminants are difficult to remove because the existence of azeotropic conditions. Take for example MTBE and methanol binary system. The figure shows the vapor-liquid equilibrium or VLE curve of the system. When the mixture is distilled, it yields a solution containing at most 85.4% weight of MTBE. This is shown at the intersection of vapor and liquid line in the VLE curve. Once this composition has been achieved, the liquid and vapor have the same composition, and no further separation occurs. Analysis of 11 components in industrial-grade MTBE found 41 azeotropes. 7 related to MTBE. There are few options to break these azeotropes. For example, using pressure swing distillation, extractive distillation, and membrane. But these approaches are complex in design and operation with high capital and operating cost. In this work, the objective is to produce high-purity MTBE with minimum 99.7% weight from industrial-grade MTBE. A direct approach to obtain high-purity MTBE is by using 2 distillation columns in series. In the first column, the MTBE is separated into middle boiling MTBE at the top and high boiling MTBE at the bottom stream. Middle boiling MTBE consists mostly of MTBE, methanol, water, and C4C5 hydrocarbons, whereas high boiling MTBE consists of components such as MTBE and tertiary butanol. The middle boiling MTBE is then fed to a second distillation column. The high-purity MTBE is obtained at the bottom, while most of the methanol, water, and hydrocarbons is in the lower boiling MTBE stream at the top of the column. Using intensification approach, we can combine column 1 and 2 into a single distillation column. The intensified column able to separate the feed into 3 output streams. At the top is the lower boiling MTBE. Middle stream is the high-purity MTBE and bottom stream is the high-boiling MTBE. The number of column vessel, reboilers, and condenser is reduced by half, which saves capital and operating costs significantly. In summary, our equipment offers: first, an intensified distillation column to process industrial-grade MTBE into high-purity MTBE. Second, it combines 2 distillation columns into a single column. Third, it saves capital and operating cost by reducing the number of column vessel, condenser, and reboiler. Fourth, it operates at reduced pressure and temperature, thus more energy efficient and safe. Our invention is first of its kind in Malaysia. It can be operated in batch, semi-batch, and continuous mode. It is made using interchangeable borosilicate parts. The column vessels is filled with industrial-grade structured packings. This pilot plant is fully made in UMP by our lecturers and technical staff. Before starting the operation, we first simulate the process in Aspen Plus to determine the operating parameters. Second, we made some modifications to meet the operation demands, such as adding temperature and pressure sensor, tanks, reboiler, pumps and controllers. Third, we designed the experiment worksheet and set the process operation values. The pilot plant startup was around 1 to 2 hours. The total plant operation was around 7 to 8 hours. Lastly, the top and bottom product were sent to local MTBE plant for analysis. Let's look at the column in action. As was previously mentioned, the distillation products were sent to a local MTBE plant for analysis. The results was promising. We were able to get MTBE with purity of 99.7 weight%. The production ratio is around 60% of feed rate. Based on the current operating condition, it is estimated the pilot plant is capable to produce 2.5 tons of high-purity MTBE per month with monthly processing capacity of 3.8 tons industrial MTBE. Based on the operation potentials, we calculate the production cost of high-purity MTBE and its monthly revenue. The production cost is estimated around 3.5 ringgit per kilogram. With market price around 16 ringgit per kilogram, it is estimated we were able to have monthly revenue of 40,000 ringgit, almost $500,000 annually. Recently, a local multinational company has shown interest in our work and meeting is being arranged to scale up the facilities. From our patent search using lens.org, we found out that only 3 patents were registered with the same title. All companies were from Europe. No patents were registered in Southeast Asia and Asia region. This shows our innovation has the opportunity to be patented. We access out TRL or technology readiness level between 6 to 7. From the results, we are optimistic that the pilot plant has the operation capability to produce high-purity MTBE. This project was led by Associate Professor IR Dr. Mohammed Riza Othman. Team members include Dr. Zulkifli Jamaat, Associate Professor IR Dr. Chin Sim Yi, Mr. Arman Abdul Qadir, Mr. Farid Abdullah, Mr. Haril Hisham Ismail, and Mr. Shafi Muhammad. Thank you very much for watching.